Good day, class. Another week of statistics and probability lessons. And for this week, we're going to talk about random sampling. If we recall last week, we identified regions under the normal curve and correspondingly to different standard normal values. We converted the normal random variable to a standard normal variable and vice versa. And we also computed probabilities and percentiles using the standard normal table. You still have it, right? Okay. For this week, we are going to illustrate random sampling, distinguish between parameter and statistic, and identify sampling distributions of statistics. Focus on sample mean. So if you're ready now, let's get it on.
Welcome everyone to my channel. My name is Mon. Sir Mon.
Okay, let's now talk about the different sampling techniques that we're going to use, especially in our research. Okay, you're doing research now, and also for next semester or next year in your grade 12, you'll be doing quantitative research. These are very important lessons, okay? So there are basically two types, the random and non-random sampling. For the random sampling, basically every element has equal chances of being selected, and random samples are unbiased representation. And this is used in blinded experiments or randomized control tests. Why blinded? You don't see, you don't select, you don't favor, there's no favoritism, okay? And the fishbowl method is the basic one, wherein all the names are placed inside the fishbowl. Okay, and then you select one at a time. So randomized. Then the next one is non-random sampling. It's non-probability sampling because you can be subjective. Okay, there is a bias on it. However, it is cost and time efficient. So let's take a look at the random sampling techniques. Okay, so let's take a look. The first one is, of course, the simple random sampling. It's very simple. That's what I explained a while ago. Okay, wherein everybody has equal chances, and then you can place all the names inside the fishbowl and then select one at a time, just similar to several draws, right? Raffle draws, okay? Assuming that the weights are the same, right? Okay, and the most popular method is fishbowl, although you can use a randomizer, wherein you generate random numbers, and then let's say you get number 25, you get the 25th name, or probably from the list, you have a list of all the members, okay, of the population, and then you select the 25th person, and that's how you do the simple random sampling, okay? That's how I illustrate it, okay? Now the next one is stratified random sampling, from the root word strata, stratified, stratum, okay? The elements are grouped by stratum before selection. So you group the population first into stratum. They are scattered physically, okay? Like for example in the whole Philippines, but share certain characteristics. For example, the grade level. Of course, there's a grade 11 in Luzon, grade 11 in Visayas and in Mindanao. Religion. You find different religions in all places. And the gender, of course, there are male and female in Luzon, male and female in Visayas, and male and female in Mindanao, and different professions. And you know what I'm saying, right? There are also engineers in one place and the other place as well. Now, it covers the whole population, but only focus on strata. And samples are better representatives of the population compared to simple random sampling because you get a representation for each stratum. Okay? Got it? Oh, there it is. You subdivide the whole population into different stratum. Okay? Now let's move on to the next, cluster random sampling. The elements are also grouped, but this time by clusters before selection. So the whole population is grouped by clusters. This time around, they are physically nearby. Okay? Meaning to say sections. Okay? So you're in one section. You're all together in one room. Let's say by school. So of course, if you belong to that school, you all belong physically and stay in that school, right? Barangay, by district, by region, okay? When the whole population cannot be covered physically, okay, you cannot do a research or survey for the whole Philippines, you can just cluster them, okay, and get samples from it. Now, samples are better, again, representatives of the population compared to simple random sampling, okay, and that's how you illustrate it with different clusters, and then you select the clusters that you want to survey or get samples from. Now, the multi-stage random sampling is, as the name implies, multi-stages, right? You group into strata or clusters, and then another sampling is used. Maybe you started with strata or stratified sampling, and then you do a cluster from that stratum, and then you do a random sampling. So any combination would end up with multi-stage random sampling. We're done with random sampling, okay, and that's how you illustrate it. So you can get the cluster first, and then from the cluster, you can do a simple random sampling. Okay, now let's go to non-random sampling. Of course, many books will contradict with my lesson, but basically this is what I learned. The first one is convenience sampling, from the word convenience. It is convenient to take. Samples are easy to contact or visit. Okay? Examples are people in the neighborhood or in the mall, like your friends around your house. Okay? Your playmates. Okay? Or you can ask them, you can select them. Or in the mall, you can stand in one corner, and then every time you see somebody arriving, you can ask. Okay? Very convenient. And the first available source to take, of course, because anybody who comes around is taken. Okay? The next one, and that's how I illustrate it, convenience. So you just select the one that you are conveniently looking at. The next one is purposive. This time from the word purpose. Okay? It's judgmental or expert sampling, of course, is logically assumed as representative of the population. The word assume. It's a manageable data, and judgment or selective oftentimes becomes subjective. Okay, like for example, I'm looking at a survey among doctors, and so I select only the doctors that I know. Okay, so I don't, of course, I will not ask engineers or other people, architects, nurses. No, I'm only looking for doctors. Okay, so based on your purpose of the study. Okay, and that's how you illustrate it. It suits your qualification, okay, for the purposive sampling. Then the next one is systematic sampling. This is where the contradiction arise, no, with other materials. They consider this as a random sampling, but in many other books, it's called a non-random sampling because, in this way, you set up an initial sample, and then you create a system of selection, like for example, every 10th, every 5th, okay, every 20th. So you make a list, right? And with a regular interval. However, it can end up as random, but oftentimes it is biased. Why? Because, if the list, okay, that you created is not randomly created at all, and then maybe every 5th could belong to one group only. And so you're not able to get a good combination of the characteristics of your population or your sample, I mean. Okay? So there you go. And the way I would illustrate it is that you can group, let's say in your class, I will assign your seats, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And I will select only one row. Okay? What if on that one row, they belong to one, one characteristic only. So I will not be able to get the characteristics of the other rows. You get what I'm saying, right? So that's why in many other books, they are considered non-random. Okay? So at this point, let's play Kahoot. Okay? And let's see. And we will have an example of that Kahoot. So I want you all to get into your laptop, into your Google, into your cell phones, and let's play Kahoot and see if you understood what we just have discussed. Okay? I'll wait for you now. Okay, let's review your answers. Okay, for the first one, we listed the names and get every 7. So there is a system that we use, and so it's called the systematic. The next one, you use a tambiolo to get all the balls, similar to lotto draws. And so it's a simple random sampling. Okay, the third one, you select from your friends conveniently, right? So it's called convenient sampling. And then the next one, group by school. So from the population, you group by school, different schools, and then you select by level. So if you notice here, you did 2 steps, group by school, and then select by level. Okay, meaning to say, from different school, you can have grade level 6, 7, 8, etc. Then, of course, it becomes a multi-stage. The next one, you choose only the barangay captains. Okay, because that is your purpose. So, therefore, it's purposive, right? And then, the next one, you group students by section. Remember, by sections. So, they all belong to one class. Okay, by section. And so, they are clustered. And therefore, clustered sampling. And then, the last one, you select 10 males and females. You group them into males and females, right? And that's considered already 2 strata, and therefore stratified sampling. Very simple, right? Okay, I hope you got it all correctly, and I am not sure who is the winner, so let's check on that later. So let's move on. Now, very important when you're understanding your research materials, okay, and when you're doing research, that you would understand the difference between a parameter and a statistic, okay? When you're doing research, the parameter is considered the numerical description of the population, meaning to say the whole population. So if you're doing a study about grade 11 students, we're thinking of the whole population of grade 11 students, maybe in Angeles City, maybe in the whole Region 3, maybe in the whole Luzon, or in the whole Philippines, right? And the data are taken from that population. It depends on your population, right? And research would limit you. You have limitation in your study. Let's say you're studying only those grade 11 students in Angeles City. So you're considering all grade 11 students in Angeles City as your population. Okay? So measurements like population mean, population standard deviation, population proportions are the ones that you are trying to estimate. Okay? Like average grades, average height, average weight, etc. Okay? So let's go on. I'll give you some example. A census was taken and the average number of children of a family in the whole Philippines. In the whole Philippines, mind you. So that 4 is equal to 8, and therefore it's from the population, right? Okay. And then another example is the average grade in statistics of all senior high school grade 11 students in Angeles. Again, all senior high school grade 11 students in Angeles in 2019 is 95.07. Again, you're talking of the population average. Okay, so those are examples of parameters. Of course, there could be parameters regarding standard deviation, variances, or proportions, which we will study in detail in future topics. Now, let's go now to statistic. A statistic is a numerical description of the relevant statistical data which are taken from your sample, from the samples that you have taken. Let's say you're talking about the whole Philippines, and you did a cluster, and you did some samples only for Luzon, and so your data will refer only to your samples from Luzon, and measures like sample mean, sample standard deviation, sample proportion. And take note of the symbols. They're quite different already. This time I'm introducing the differences between the population symbols and the sample symbols, okay? An example would be a survey was taken and the average number of children of 20 families in Sapang Bato is 8. Remember, we're talking only of the 20 families that we sampled. Okay, I'm pretty sure there are more than 20 families in Sapang Bato. Okay, and the next one is the average grade in statistics of selected 40 Aksay Senior High School grade 11 students in 2019 is 95.07, meaning to say we sampled only 40 students, and I'm pretty sure again there will be more than 40 grade 11 senior high school students of AXI in 2019. Okay, you got the idea? Okay, so again, let's play Kahoot. And this time around, I'll give you some statements and you think if the data given will be considered a parameter or a statistic. Okay, so you just select it is a parameter or it is a statistic. Okay, I'll give you time to enroll in your Kahoot and I'll give you the number to join. Okay, again, let me explain the answers. In the first part, number one, the average grade of all seniors high school students in mathematics is 87. And it is obviously a parameter from the keyword all. Okay, from the keyword all. Number two, 20% of 760 adult males prefer doing sports excluding females. Wow, that hurts. Of course, it's a statistic because we only surveyed 760 adult males. Obviously, there will be more than 760. Number three, a survey of 3,251 college students found that 38% think that higher education costs higher than what it should relative to its value. And of course, it is statistics because we only surveyed 3,251 college students, which obviously the population will be more, right? And 62 of the 97 passengers aboard the Hindenburg airship survived its explosion. And the reason it is a parameter is because there are actually only 62, no? Only 97 passengers. Okay, we measured 97, okay, passengers. So that's the total passengers aboard. Now, number five, in a survey of 600 computer users, again, 8% said that their computers had malfunctions that needed to be repaired by service technicians. And the answer would be, of course, statistics because we only surveyed 600 computer users, which obviously there are more. And number six, in January 2014, 60% of the 24 Philippine senators are against death penalty. And of course, we're talking of 24 Philippine senators, which is the totality, okay? That's the total number of senators in the Philippines. So it becomes a parameter. Number seven, an average of 752 bags were sold by ABC company for its entire operation until bankruptcy. It's going to be parameter because that's the totality, the entire operation already. Okay, number eight, viewers rating show that 34% of 2,500 adults watch Channel 5. Of course, it's going to be statistics because we only surveyed 2,500 adults. And in number 8, in a recent year, the NSAT for all graduates was 21.5, and therefore it's a parameter because we're talking of all graduates. And the last one, a survey of 1,500 adults found that 65% think that China's emergence as a world power is a major threat to the well-being of all the countries considered first world. Okay? Now, this is going to be statistics because we only surveyed 1,500 adults. Okay? So, let's move on. Again, just a review, the population is like the universal set, the totality of all possible respondents, and the sample is like a subset, the set of respondents forming a smaller group which are taken from the population. I hope the concept is clear to everyone. Okay, now let's take a look at the population mean, variance, and standard deviation. Take note of the notations, the symbols. We have mu for the mean, the sigma square for variance, and the sigma for the standard deviation. If you notice, we have already exercise on this population mean, which is the summation of xi over n, or the summation of the frequency of each xi multiplied by the xi divided by n. And the population variance is equal to the square root of the differences divided by n, or the frequency multiplied by the difference squared, sum it all up, divided by n. And another formula which can be found in other books will be the summation of the quantity of the square of xi multiplied by its probability and then the total of that, you deduct the square of the mean. Okay, and so you come up with the standard, the variance. And of course, standard deviation is very simply, in all cases, the square root of the variance. Okay, now in our example previously, wherein we have a series of numbers, we calculated them, and we found out that we have an average of 3.2 using the first formula and the second formula. Okay, you can recall that. Okay, and for the variances, we also calculated the variances using the two formulas, and we both came up with 2.96 using formula 1 and using formula 2. And of course, here we totaled the frequency multiplied by the differences squared, and you come up with 29.6, and we divided it by 10. Take note, we divided it by the number of samples, okay, the 10. And so we came up with 2.96. And of course, the sigma, which is the standard deviation, we just simply took the square root of 2.96 and you come up with 1.72. Now, we're done with the population. Let's take a look at the sample mean. If you notice, the formula for the sample mean is very much similar to the population mean. Okay? However, let's take a look at the variance. Okay? We will not be using the second formula for variance. Okay? But simply the summation of the square differences divided by n minus 1. Take note of that denominator, n minus 1. Okay? Or if you have frequencies, you have the frequency multiplied the square of the midpoint minus the mean. Of course, the midpoint could be x if it's a singular grouping, or if you have groupings, you take a look at the midpoints. Okay? And again, the one that you have to take note is the denominator, n minus 1. So we subtract 1 from the denominator. And so again, we take a look at our sample, and still we come up with the same mean because we're using the same formula, obviously, 3.2. However, in the variance, since we are dividing the total 29.6 by 9, we now come up with 3.2889. Okay, and if we are going to get the square root, okay, we get 1.813. So you take a look at the differences. Variance for population using the population formula is 2.96, but using the variance formula for sample is 3.29. Okay, the mean values are the same, obviously. Now, the sampling distribution. What is a sampling distribution? Just like any distribution, it is the graph of a statistic for your sample data. Meaning to say, if you get the sample, okay, I will graph them. Maybe it will form a normal curve, maybe it's a uniform or flat curve, maybe it's an increasing, maybe it's going down. So it depends on your data. Now, it is the distribution plot of the sample data. I mean, going back, the keyword is sample data. That's why it's called sampling, okay, from the keyword sample. And we can have different shapes or form, as I've said. And we can have class heights, weights, ages, etc. For example, in your class, what would be the distribution of the heights? How many are 4 feet tall, 5 feet tall, 6 foot tall, and then 8, 9, and 10, etc. I am not so sure if there is an 8 foot tall here. Okay? So it could be the different weights. No, let's not talk about weights. I might be accused of being biased. Okay? Or ages. Or probably your ages would be good because you're all will have similar ages. Okay? So one example is another one. This time, the sampling distribution of the sample means. Now, those are two different things, right? The first one is for all the samples. Okay? And the next one is for the sample means. Meaning to say, I can have the average height in your section. Then I'll go to the next room, the next section, I'll get another average height, and then I'll go to the next section until I get all the averages of all sections from grade 6 maybe up to grade 12. Okay, so I'm talking about all the sample means. Get the idea? Not the spread of all the samples, right? So this time around, the graph of all x bars for your sample data is what I'm going to plot. And then you have to notice that the mean of sampling distribution of the means, meaning to say the average of all the averages, will be equal to the average of the whole population. Wow, interesting, right? I wish we're going to have a face-to-face so I can illustrate this clearly with you, okay, with a good example. Now, it follows the normal curve also, okay? And from the central limit theorem, okay, we are going to get a normal distribution of the distribution of all sample means. Okay, take note of this, huh? Now, what is this central limit theorem? Let me add this to your lessons for this week, which is not in your LAS. The central limit theorem says that given a population with mean mu and a standard deviation sigma, when you take sufficiently large random samples, meaning to say you get a lot of samples from that population, okay, with replacement or whatever it is, the distribution of the sample means will follow a normal distribution. Oh, isn't that interesting? Okay, now, meaning to say, if you follow, okay, and increase the number of samples, okay, and then you would notice that your curve will become more smooth. Remember the example that I gave you regarding the tossing of coins probably last week, okay, when you toss 5 coins, 10 coins, 20 and 30, did you notice the curve is getting smoother? Now, we're talking there of the individual. But even so, if you get the distribution of the averages, you will notice that it will also follow a normal curve. Let's take a specific example here. Given the population 1, 2, 3, 4, 5, it could be different persons, okay? It could be person 1, 2, 3, or different balls, different number, colors, etc. How many unique samples of three members can you create? Of course, applying the combination formula, you end up with a combination of 5 taken 3 at a time. And so 5 factorial over 3 factorial multiplied by 2 factorial at the bottom, the numerator, you end up with 10. So let me take a look at that. So I can have the first sample as 1, 2, 3, the second sample as 1, 2, 4, the third sample as 1, 2, 5, etc. until I have the 10th sample as 3, 4, 5. They are all unique, right? There's no similarity. Because if I have a 3, 2, 1, it's the same as 1, 2, 3. It's the same grouping, right? So I don't have a 3, 2, 1 here. Because a 3, 2, 1 is the same as 1, 2, 3. Meaning to say, if that is Pedro, 1, and Carlos, even if you change the order, Carlos, 1, and Pedro, they're the same persons, right? So that's how I group them uniquely. Okay, so if I take a look at the sample means of each, so I'll get here 2, 2.83, 2.67, the third group, 2.67 again on the fourth group, 3, 3.3, 3 again, 3.3 again, 3.67, and then 4 on the 10th group. If I graph these x bars, okay, so I'll have 1, 2, okay, and then the 2.3, there's only 1 also. The 2.67 is somewhere here. Of course, it's more than 2.5, okay, and so I'll end up with 2 of that, 2 of 3s, because you have 3, 3 there, and 2 of 3.33. Again, there's only one 3.6, and then there's only one 4. So if you look at it, it forms a normal curve, although it's not smooth. Okay, but if I look at the mean or the average of all the averages, okay, you have 2, 2.3, 2.6, 3, 3.3, etc., and you have the frequency here. So you have all the probabilities. You will end up with an average equal to, okay, if you take a look at it, you'll end up with an average of 3, which is also the center here. Okay, so there you go, class, and I hope you get a good view of what a sampling distribution is all about. We will probably talk about it in details in future lessons, but for now, I was just introducing you what a sampling distribution is all about. Of course, as I mentioned, it could be a sampling distribution of all the individual values or a different distribution for the sample mean. And as the law dictates, the sampling distribution of all the means follows a normal distribution curve. Okay? So, let's see. Well, wow, we're done again for this week. Check your LAS or any online activity for this topic class. And I hope for this week, you're going to join the activities, or you're joining, or you have already joined activities for the math week. Okay? As I've said in our classroom announcement, good points await you when you join your activities in your math week. Okay? So, again, thank you for being with this lesson for this week. And I hope I'll be able to convince you more into learning what statistics is all about. Okay? Let's have a good discussion after this video lesson. And I want you all to keep safe, everyone. And see you again next week. Bye for now.